Welcome to the Robotics and Digital Media program. This is a customized program created by Discovery World's Experience team for freshman engineering students at UW-Milwaukee. We built robots inspired by nature. We also learned how to conduct interviews and communicate scientific topics. Discovery World is a center for public innovation. The purpose of the program is to encourage innovation by fusing robotics with biomimicry, creativity, and digital media production. As students and tomorrow's engineers, we discover, innovate, and lead.
This is Innovation House, the robotics and digital media podcast produced by Discovery World and sponsored by the Forte program.
Forte stands for Fostering Opportunity for Tomorrow's Engineers. We are tomorrow's engineers. I'm Anthony.
And I'm Avery. We are engineering students in the School of Engineering and Applied Science at the University of Wisconsin-Milwaukee.
Today we're going to explore biomimicry and robotics.
We also have a fascinating interview with Leah Enders, a biomechanical engineering graduate student who works in the hand rehabilitation lab at UWM.
We talked about her work and her love of engineering.
But first, here's a question. Why do we love engineering?
I'm Ashley. I love math and computer engineering.
Hi, my name's Avery. I'm really into engineering because it combines art, math, and science.
My father has encouraged me to pursue math and science. He sees my potential and that motivates me.
As a future engineer, I would love to create the framework for transferring our consciousness to virtual environments.
We'll be able to interact with the world in a new way. We'll see ourselves in a new way.
As a future engineer, I want to create a mechanical exosuit. It will use hydrogen, air, and solar power. It will be used in construction, law enforcement, and defense.
As a future engineer, I want to develop new ways to move and control cameras for video and time-lapse.
I want to use my knowledge in engineering to help other people, whether it's making their life easier or by keeping them safe.
If I could help create a brighter future for my community, I would design a prosthetic where the user would feel every sensation in their arm.
My love of computers began when I could finally access computers in Poland. From then on, I was hooked.
I see engineering in every part of my life. Engineering inspires me to contribute to humanity in a tangible way.
I see engineering in bicycles, and it inspires me to build a better frame geometry.
I love the idea that we can transform something like water flowing down a hill into electricity.
I find electricity interesting because it's something you cannot see, but in a way, you can predict it and use it towards your advantage.
I enjoy building robots because they're complex and creative, yet elegant in their own way.
One thing that I'm really proud of is that I built a computer that I used for 3 years. Using something every day that I put together by myself is really satisfying.
While in high school, I helped to design a pneumatic arm for our robotics team. I love the whole design process.
Engineering combines creativity, analytic thinking, and problem solving.
Engineering combines ideas, materials, thought, and action to create new products and new ways of living in the world.
And that's why I love engineering.
And that's why I love engineering. My name is George, and that's why I love engineering.
As engineering students, we love robots.
Lots of robots are designed to mimic the movement and behavior of animals, fish, insects, people, things like that.
This kind of design in engineering is called biomimicry. It's a way of exploring the natural world and applying what you learn to solve engineering challenges in the built world.
The team here at Discovery World challenged us to design and build a robot inspired by plants.
So we chose our plants, we did some research, and watched the plants in action.
We even dissected a flower and looked at it under a microscope in order to learn how plants work.
The more that we explored the plant world, the more we began to see that plants are a great inspiration for robotics.
Hello, I'm Brian Radke, and I'm an electrical engineering student at UWM. I constructed a robot to mimic the common bean plant. The common bean plant, or known as the edible green bean plant, is grown in many regions throughout the United States. Like any other plant, the leaves on the plant want to move towards sunlight. How the common bean plant works is when direct sunlight hits the leaf, it causes a chemical to move towards the darker side of the leaf. The chemical causes the cells on that side to elongate, which then turns the leaf towards the sun. On the base of my robot, I have the brick, which is the brain that contains the program. Coming out of the top of the brick are the wires that go to the motors, and coming out of the bottom of the brick are the wires that go to the light sensors that take in the different light values. In this part of the robot, it is supposed to mimic the stem of the plant, and on this part of the robot, it's supposed to mimic the actual leaf of the common bean plant. In the stem of my robot, I have two motors. The bottom motor controls the left and right movement of the robot, where the top motor controls the up and down movement. In the leaf of my robot, I have 4 light sensors that work together in pairs. We have the top light sensor and the bottom light sensor that work together, and the right light sensor and the left light sensor that work together. Each light sensor takes in a different light value. The program compares these light values so the robotic leaf can move towards the light source. Like a real plant, the program is constantly checking light values, so it can make sure that the robotic leaf is always looking at the light source. For my demonstration, I'm going to turn the lights down. This light bulb here represents the sun. The program is constantly going back and checking the light values to make sure that the leaf is constantly moving towards the sun. And there you have it. Programming was challenging with the light sensors and the light values. The first 3 programs failed. I eventually used an advanced logic circuit that helped the leaf follow the light. I had a blast using engineering and nature to design a robotic plant.
Hello, my name is Matt Padella, and I'm a mechanical engineering student.
And my name is Anthony Kupcho, also a mechanical engineering student.
Our robot was inspired by the Dwarf Mistletoe plant, which can be found around Nevada.
What makes this plant interesting is that it builds up liquid pressure behind the seeds and is then able to fire them up to 50 feet. And then the sticky residue on the seeds themselves attaches to other plants or animals and then grows roots.
Our robot was designed to look like a dwarf mistletoe plant growing from the branch of another. The winch down here stores elastic potential energy in the seed pods above. When enough energy is stored, the pin will fail, causing the elastic potential energy to be released, and the seed will fire out of the top.
And now time for a demonstration. Matt, if you would. One design challenge that we had working with Legos was finding a replacement for fluid pressure, and what we came up with was to use rubber bands. So instead of storing pressure by building up water, what it does is pull back on the rubber band, storing elastic potential energy. I had a lot of fun working with Matt here to design a robot plant.
And it was fascinating recreating something from nature.
Hello, I'm Benjamin, and I'm a mechanical engineering student at the University of Wisconsin-Milwaukee.
And I'm Tommy, a computer science major.
And our robot is inspired by the Telegraph Plant.
Like every plant, the Telegraph Plant wants to get as much sunlight as possible. Each large leaf has a hinge, and each large leaf can move and follow the sun.
But this takes a lot of energy, so the Telegraph Plant has tiny leaves that search out and detect light.
It does this in the morning when the rays of the sun are red.
Here we have our robot that biomimics the Telegraph Plant. At the very top, we have 2 small leaves that oscillate left and right to look for the light. We have a color sensor up here that determines whether the plant sees light or not. And then down here, we have 2 motors. One oscillates the 2 leaves, and the other motor raises the large leaf up and down, which is this right here. So the Telegraph Plant only works when it's during the day. And how the Telegraph Plant determines this is when the sun rises and when the sun sets. When the sun sets and when the sun rises, the most dominant light in the light spectrum is red light. So we have the color sensor located at the very top, located on a very small leaf, finds the red light, and it raises up the large leaf. So if we put the blue light above, The smaller leaf is oscillating back and forth until it finds the red light, and it's not being triggered yet. So now we're going to switch over to red light, and the large leaf raises up.
One of the challenges we had was programming. It took a lot of trial and error just to get the programming right.
This was a really fun challenge. Building robots inspired by plants was really new to us, and we enjoyed working together to get our Telegraph Plant robot to work. I'm Ben.
And I'm Tommy, and this is our biomimetic robot.
Recently, we interviewed Leah Enders. She shared her work on biomechanics with us.
Hello, my name is Matt Padella, and I'm a mechanical engineering student at the University of Wisconsin-Milwaukee.
And I'm Brian Radke, an electrical engineering student at UW-M.
Our fabulous guest today works in the Hand Rehabilitation Lab at UW-M.
She's a bioengineer who focuses on the fascinating biomechanics of the human hand. Her studies have brought her from Pittsburgh to UW-M.
Leah Enders, thank you for joining us today.
You're welcome.
And what exactly is biomechanics?
Biomechanics is the study of the human body and how external forces work on the body.
You focus on the human hand. What makes the human hand so remarkable?
The hand is actually a very uniquely remarkable system. It has the ability to not only follow commands and their exact commands, and where it's very necessary when you're dealing with a lot of fine manipulation throughout the day. It's also a great system in that it also takes information in and it sends that to your brain so you can see the differences between surfaces. You know that you have just gripped a square block versus a circular object, or a higher friction or a lower friction surface, which is needed to not only so you don't drop objects, but also so that you're successful and you're efficient in your grasping.
If you had to trade hands with another primate or mammal, which would it be?
Well, I'd have to say a monkey. And one of the reasons is that the human hand, like we just said, is a very unique portion of the human body. And one of the reasons is that we really have independent fingers, finger movement abilities. What this means is we have decreased synergy between our fingers. And that means that we have the ability to move each of our fingers independently. And you'll notice that everybody knows that when you try to move your pinky finger, that the ring comes along. So that's an example of a synergy between two fingers. And we are unique in the fact that we can move our thumbs all the way. We can circumduct our thumbs all the way. And that's very important when we're trying to grasp different objects. And monkeys have the next ability to do this, and they have almost the range of motion that we do.
And then when you were younger, did you have anybody who inspired you?
I had to say my mother. My mother went back to school when I was in elementary school and middle school to become a nurse. And so I saw what she struggled to get through raising 3 girls and going to night classes to become a nurse. And so we would often accompany her on her college classes. And I saw what it was like to kind of go back and do school. And so I knew that I wanted to go to college. I wanted to do it early.
So, was there anyone who inspired you to go into engineering?
Yes, my stepdad is a mechanical engineer. He was going back to school the same time my mother did. And he really saw engineering as a great career path to go into and a very employable path to go into. And my mother's, like I said, a nurse, so mix the two together and you get a bioengineer, which is where I ended up.
What's the most fun you've ever had doing what you do?
I am currently very involved in an organization called Engineers Without Borders. And at UW-M, we are focused on bringing clean water to villages in Guatemala. And I have gone on trips with them. I've gone on one trip with them, and I still work with them on their upcoming projects as well. And when I'm down there, I get to go and help educate about health and safety and water usage and clean and healthy habits for everyday activities. And I really just enjoy talking to the people and getting to talk with all the different types of people, not only in my laboratory where I have stroke survivors and students, but also with these villagers who, have never even seen a TV.
So what are some of the cool and fascinating tools you get to use in your lab?
Okay, so there are 3 current things going on in our laboratory that I think are pretty cool. There's one that's called transcranial magnetic stimulation, which essentially use a magnetic coil to stimulate the motor cortex and send a command from a person's brain for their hand to move. One of my comrades uses that. Another setup that we have in the laboratory is looking at release strength of a ladder. So the person sits in a chair and then a motor will hoist up a bar and the person has to see how long they can hold on to it before they have to let go, which is a great indication of what someone's ability would be if they were to fall from a ladder in a workplace setting. And one of the things that I get to work at is I get to look at really precision measurement systems dealing with the finger forces. And what that means is that I get to measure forces from the hands in many different directions. And I get to measure all these forces really have a lot to do with how we're adapting to surfaces and how well we're holding these surfaces. And it really gives us a good picture of how efficient someone is doing at gripping it.
What message would you like to share with someone considering engineering as a career?
I would say that engineering is a great career option. You exit the programs, for the most part, being completely employable. That's how the programs are set up, so that you exit having real-life skills that any company would be proud to take on board. Also, I would say that you don't necessarily have to be quote-unquote math-minded to go into engineering. I think that you can learn anything if you just kind of realize how you learn and adapt your learning processes to that. I'm not someone who did very well my first couple years of engineering, and it took a long time for me to learn how I study, and I had to kind of take the time to turn all of my studies into a way that I would remember them.
Leah, thank you for sharing your incredible work with us today.
Thanks for having me.
For the Robotics and Digital Media program at Discovery World, I'm Brian Radke.
And I'm Matt. At UWM, we discover, innovate, and lead.
We'd like to thank Leah Enders for joining us.
We'd also like to thank Discovery World and UWM's Forte program for making all of this happen.
Discovery World is a center for public innovation. At Discovery World, we explored robotics, digital media production, and communication skills. We tinkered with new ideas like biomimicry and turned those new ideas into something real.
And that's what engineering is all about. Discovery World's experienced team worked to help us discover, innovate, and lead.
The randomness and efficiency of nature really inspires me.
Nature inspires me. The repetition of patterns in nature, such as the golden ratio, are fascinating.
I'm fascinated by a plant's ability to generate energy using only water, nutrients, and sunlight.
In a way, we recreate lightning every time we turn on the light. It's humans recreating what we see in nature.
Animals, plants, and weather are things in nature that inspire me. And as a future engineer, I will use nature to design new things.
Nature is the ultimate test of durability.
I'm really into computer science, but nature also inspires me because it has laws and systems that hold everything together perfectly.
I think nature can help us today because nature's been redesigning life for billions of years, whereas we've only just begun.
I think the study of biomimicry, nature, and humans can define the future of artificial intelligence.
Biomimicry brings awareness to engineering because it opens up new possibilities of interpreting the world.
Engineering combines problem solving, experimenting, critical thinking, nature, design, biomimicry.
When engineers and scientists create machines and medicines, they often base those things off plants and animals. Understanding plants and animals can reveal better ways of innovating.
I'm Ashley, and that's why I love engineering.
And that's why I love engineering.